Alright, so for today we're talking about 4.6 triangles, equilateral, right, and isosceles. There's 3 boxes we're going to try and cover today. We've got about 10 minutes to do it. So let's see how much we can get done. The first box, I'd like to introduce to you 2 new theorems. One's called theorem 4.6, and the other is called theorem 4.7. It's not so important like the names of them, but in terms of what they are, okay? The first one is called the base angles theorem. Yeah. Okay. And here's what the base angles theorem says. So draw yourself an isosceles triangle. Okay. It says this. It's an if-then statement. If some stuff happens, then some stuff happens. So there's a hypothesis and then there's a conclusion. Yeah? First one says this. If two sides of a triangle are congruent, if two sides of a triangle are congruent, then the opposite angles are congruent. So, here's what that means. If I was to highlight this side here, okay, see that side that I have highlighted in yellow? What is the opposite angle to that side? Yeah, that's this one down there, right? So this angle and this angle must be congruent. So this is called the base angles theorem. Okay? And then tonight, please put that in your toolkit. I'm going to speed up the lesson because we only have about 10 minutes left. So tonight, put that in your toolkit and put that in your toolkit as well. Okay, so the base angles theorem says if two angles of a triangle are, if two sides of a triangle are congruent, then the opposite angles are also congruent. Now, 4.7 is the converse of the base angles theorem. Okay, what is a converse? Who remembers what a converse actually is? When you have an if-then statement, how do you find the converse? If P, then Q, how do you find the converse? If Q, then P. So what do you do with the hypothesis and the conclusion? You just switch them, right? So if I had these exact same pictures drawn over here, okay, and an isosceles triangle, if I gave you an if and a then, do you think you could come up with it on your own? All right, what would it be? There you go. If, why don't we say this? If two angles of a triangle are congruent, then what? The sides opposite the angles are congruent. So if I were to give you a picture and I said that those two angles had to be congruent, what is that guaranteeing you? What does that automatically tell you? It tells you what? That side and that side are what? Congruent. Good job. There you go. Okay, so there's everything from the first box, right? The base angles theorem and the converse of the base angles theorem. So a guiding question could be, what is the converse? Okay, so you might want to have to remind yourself, hey, what is this word converse all about? What is the converse? Okay, for the second box, I'd like to talk about 2 corollaries. You okay? Someone like breathed heavily. Corollary, so 4.6 and 4.7. Here we go. And this one, draw yourself an equilateral triangle. Looks like that. These are also two if-then statements. Okay, so let me give you for the first one. If a triangle is equilateral, E-Q-U-I, if a triangle is equilateral, what do you think that says about all these angles inside here? They're all the same. Then the triangle is equiangular. Okay, in the spirit of the lesson, what do you think the converse is? You got it. You got it. If a triangle is equiangular, then it is equilateral. Okay, so those are the corollaries, and you might want to put those tonight in your toolkit as well.
What would we call that?
Corollary 4.6 and corollary 4.7, yep. Okay, last idea here, simple example I'd like to show for you, so I can send you off into the next period, okay? Here it is. Please draw this picture right here. Okay, our goal is to find x and y. Let's start with this triangle here that I've highlighted in yellow for you. What type of triangle is that? It's an equiangular triangle. Equilateral triangle. If it's equilateral, then it has to be what? Equiangular. So that means all of these have to be the same. And if all of them add up to 180, so if I just take 180 and divide it by 3, x would have to be what? 60 degrees. There you go. Now, if this is 60 degrees, what is all of this? 180. So 180 take away 60 is how much? So that means that this has to be 120. Now, if this is 120, take a look at this triangle. This side and this side are the same. So that tells you that the angle down here and the angle up here, which is y, has to be the same. So if there's 120 degrees at the top, that means there's 60 degrees left over. And if we split that equally, what does that tell you y has to be? 30. Y has to be 30. What do you think about that? Not too bad, right? Okay, so in your toolkit tonight, make sure you put the new theorems and the corollaries.